For the remainder of this lesson, we will talk about how to evaluate compositions of trig functions with inverse trig functions. And there's four possibilities. The first two possibilities are listed right here. So you could have a trig function composed with its own inverse. And there's two ways in which you can arrange that to happen. The first possibility is when the inverse function is inside, and that's these three equations right here. The inverse function could be inside. The other possibility is when the inverse function is outside. The last two possibilities, which we will discuss later, would be when you have combinations of a trig function and its inverse and an inverse trig function, but they're not necessarily the same type. So for example, you could have cosine evaluated with sine inverse, or sine inverse evaluated with tangent, and so on. So those are the four different possibilities you could have. So let's focus on the first two possibilities, where you can compose an inverse, a trig function with its own inverse in either order. So the inverse function can be inside or outside. Of these two possibilities, it turns out that the only problematic one is actually the second possibility when the inverse function is inside. Outside. When the inverse function is inside, is really no problem at all. No problem whatsoever. There's two things that could happen. So suppose I want to compose sine with its inverse x. Question is, what is this? Well, under ideal circumstances, a function and its inverse cancel each other off, and we would just get back x. That's under ideal circumstances. And the ideal circumstances is whenever this makes sense. Whenever I'm plugging in a number that makes sense, or in other words, a number that is in the domain of sine inverse. Because, for example, if I was trying to plug in a number such as 2, then 2 is not within the correct bounds, the correct bounds being -1 and 1, so this doesn't even make any sense. You tried this in a calculator, it is nonsense, you would get error. So this does not exist. This is nonsense. So that means that sometimes it's going to be nonsense, sometimes it's going to make sense. And in the case in which it makes sense, they do cancel each other out. So there's only two possibilities. When the inverse function is inside, either the expression doesn't make any sense at all because the input is not within the bounds, is not within the domain between -1 and 1 for the case of sine inverse and cosine inverse, or it is in the domain, and in that case, they automatically cancel each other off. So for example, sine and sine inverse of, let's see, think of a number between -1 and 1. Let's say -1/4. -1/4 is between -1 and 1, so in that case, they will cancel each other off, and you get -1/4. Okay? So that case is really not a problem. As long as it makes sense, they do cancel each other off. That's it. The other possibility is a more interesting one, and that's the one we're going to focus. When the inverse function is outside. Okay, how do you deal with that case when the inverse function is outside? When the inverse function is outside, again, under ideal circumstances, a function and its inverse cancel each other off. So under ideal circumstances, this should be x. However, the problem is that sine inverse is not necessarily going to spit back out what you started with, because sine inverse only spits out angles between -π/2 and π/2. Meaning that if to begin with I put in an angle that is way too big, I'm never going to get it back. And I'm never going to get it back because sine inverse is only going to spit out an angle between -π/2 and π/2. So if I plug in 2 pi, the sine inverse is not going to spit back out 2 pi. Okay, if you start with 2 pi, you're never gonna get back 2 pi. It's not gonna happen. So only if x is between negative pi over 2 and pi over 2, this would work. If it is not between negative pi over 2 and pi over 2, then if it's out of bounds, you have to replace it with an angle that is within bounds, that is within the domain, and then try again, then evaluate it. So let's do this with an example. So suppose I want to evaluate this. Okay, this is a special angle because 3 pi over 4 is a multiple of pi over 4, which is a special angle. So we're doing this without a calculator because we don't want decimals. Okay, so just think about it. You see, under ideal circumstances, these would cancel each other off. So under ideal circumstances, I would get 3 pi over 4. The problem is that 3 pi over 4 is not within negative pi over 2 and pi over 2. So I could never get it back from sine inverse. This is not going to be 3 pi over 4 because 3 pi over 4 is not in negative pi over 2 and pi over 2. So it is impossible to recover it. So what to do then? What you do is you think of another angle that is within bounds, that is in the domain, but that doesn't really affect the value of the sine. So let's think about it for a second. 3 pi over 4 is right here in the second quadrant. First, figure out what quadrant you're in. 3 pi over 4, 3/4 is smaller than 1, so 3/4 pi is smaller than 1 pi. 1 pi is right here. And 3/4 is also bigger than a half. 3/4 is bigger than a half, so this is bigger than pi over 2. So you're between pi and pi over 2, that means you're in the second quadrant. Okay, so this is 3 pi over 4. The thing is, we want to replace 3 pi over 4 with another angle that is between negative pi over 2 and pi over 2 that has the same sign. Okay, because we're talking about sine. That has the same sign. Okay, sine is the y-coordinate. It's associated to the y-coordinate. So I want another angle that has the same y-coordinate. The y-coordinate is the height, okay? So I want another angle that has the same y-coordinate, and it is that angle. That's the angle that has the same y-coordinate. So the question is, what is this angle? That angle happens to be pi over 4. Okay? This one is pi over 4 because this is pi minus 3/4 pi, so that's pi over 4. That's the reflection, so this is pi over 4. So now, because this angle has the same y-coordinate, that actually means it has the same value for sine, because sine is the y-coordinate. In other words, sine of 3 pi over 4 is the same as sine of pi over 4. Right? It's the same. And that helps a lot because now this is what we can do. We can say, okay, then if this is true, and it is, I can replace sine of 3 pi over 4 with sine of pi over 4 because it's exactly the same thing. So that means sine inverse of sine of 3 pi over 4 is the same as sine inverse of sine of pi over 4. I can do that replacement. And now pi over 4 is within bounds. Pi over 4, now it is between negative pi over 2 and pi over 2. So this works the way we would like it to work, meaning now sine inverse and sine cancel each other off. So you would get pi over 4. And that's the final answer. Okay, so that's how that works. Let's do another one. It says evaluate cosine inverse of cosine of negative pi over 3. Okay, negative pi over 3, first thing you should check is it within bounds? Is it in the correct place between 0 and pi? Because if it is, then you could just cancel cosine inverse and cosine. If it is in the correct place, these two would cancel each other off, and you can write down the answer immediately. It will be done. However, the problem is that this is not, negative pi over 3 is not where it's supposed to be. So these are not going to cancel each other off because negative pi over 3 is not between 0 and pi. And that's the problem. If it were, cancel, that would be the answer, but it's not. So what we're going to do is we're going to replace negative pi over 3 with another angle that has the same cosine, but is where I need it to be, which is between 0 and pi. So let's draw a quick picture. I want to draw the angle negative pi over 3. Negative pi over 3 is right here. Okay, that is negative pi over 3. I want an angle that has the same cosine but is in quadrant 1 or 2, between 0 and pi. Cosine is the x coordinate. So I want another angle that has the same x coordinate. Another angle that has the same x coordinate would be right here. That angle right there has the same exact x coordinate. So that means the angle that I want is this. Okay, that's the angle that I want. And that angle, just a reflection, this is pi over 3. So writing down what that means, because these two have the same x coordinate, that means they have the same cosine. That means the cosine of negative pi over 3 is actually the same as cosine of pi over 3. And by the way, we know that this is also true because cosine is even. So that's another way to figure this out. Cosine is even, so we could have just say, oh, cosine is even, so you can drop that minus. So you get that. Either way, this is true. All right, now the point is that I can now replace this with that and say that cosine inverse of cosine of negative pi over 3 is the same thing as cosine inverse of cosine of pi over 3. And now pi over 3 is exactly where I want it to be. I want it to be between 0 and pi for cosine. So now they cancel each other and you get pi over 3. And that's the final answer. Okay, so see why I told you that you're supposed to memorize what's the domain and the range of cosine inverse and sine inverse and tangent inverse, because at each point you have to know what's the interval where you want it to be. Sine inverse is between negative pi over 2 and pi over 2. For cosine inverse is between 0 and pi. And for tangent inverse is between negative pi over 2 and pi over 2. So you need to know that in order to solve this problem. Okay, I have a few more examples right here. Let's do another one. So this one says, evaluate sine inverse of sine of pi over 3. Okay, first of all, under ideal circumstances, sine inverse and sine would cancel each other off. And that will happen if this is in the right place. So what is the right place for sine inverse? Negative pi over 2 to pi over 2. Is this angle between negative pi over 2 and pi over 2? The answer is yes, right? So because it is between negative pi over 2 and pi over 2, this works the way it should, okay? These two cancel each other off, so the answer is pi over 3. And that's it. So this one was really easy because that's in the correct place between negative pi over 2 and pi over 2. So This is true because pi over 3 is in the interval between negative pi over 2 and pi over 2. Good, that's it. Okay, if you're understanding so far, give these two a try. If not, stick around. But if you think you're understanding, pause the video and try those two. Okay, let's do it. How about this one? First of all, is 2 pi over 3 in the right interval? If it is, these two will cancel each other off and I will just write down the final answer. But actually, this is not, unfortunately. This is not going to be 2 pi over 3 because 2 pi over 3 is not in the interval negative pi over 2 to pi over 2. So that means we need to replace this angle with another angle that has the same sign but lives in this interval. Okay, and a picture will help. So let's draw a picture. 2/3 pi, or 2 pi over 3, 2/3 is between 1 and a half. So that means this is in the second quadrant. Somewhere, doesn't matter, draw it there. Okay, so that angle is 2 pi over 3. Okay, we want to replace that angle with another angle that has the same sign. Now, sign is the y associated with the y coordinate. Sign is the y coordinate. The y coordinate is the height. So I want another angle that is at the same height, and there it is. So that's the angle that I want, and that angle is pi over 3. Okay, it's pi over 3 because this is 2 pi over 3, and this difference right here is pi over 3, and this is a reflection, so pi over 3. Pi minus 2 pi over 3 is pi over 3. All right, so we found it. That angle has the same sign because it has the same y coordinate. So what this means is sine of 2 pi over 3 is the same as sine of pi over 3. And now I can replace this with that because it's the same thing. So in other words, sine inverse of sine of 2 pi over 3 is the same thing as sine inverse of sine of pi over 3. But now, pi over 3 is between negative pi over 2 and pi over 2. So these two cancel each other off and give you the answer pi over 3. And that's the end of that problem. Okay? Now, you should try this one if you haven't tried it yet. And if you did, let's compare notes now. Question is, what is that? Well, first of all, ask yourself, are you under the ideal conditions so that these two cancel each other off? Well, for cosine inverse, the ideal conditions is for the angle to be between 0 and pi. If this is between 0 and pi, these two cancel each other off and we will get our answer. And it is. 2 pi over 3 is between 0 and 2 pi, so indeed these two cancel each other off and the final answer is 2 pi over 3. And it's over. Because 2 pi over 3 is in the interval between 0 and pi. To summarize how to evaluate composition of trig functions with their own inverses, there's two possibilities. Either the inverse function is inside or the inverse function is outside. If the inverse function is inside, then as long as the x is in the domain, these two are always going to cancel each other out. As long as it makes sense to plug in x, these always are going to cancel each other off and you're going to get back x. So you have to then memorize what is the domain of that. And the domain of that is between -1 and 1. So if you try to plug in a number that is not between -1 and 1, such as 2 or 3, then that is absolute nonsense and the answer does not exist. Okay, so as long as it's in the domain, what is the domain? The domain is between -1 and 1. As long as it's in the domain, they will cancel each other off. So this is not really a problem. It's either they cancel each other off or does not exist, period. The other possibility is when the inverse function is outside. And in this scenario, if the angle is in the range of sine inverse, then these two are going to cancel each other out. And you have to memorize that for the sine inverse, the range is between -pi/2 and pi/2. So if the angle is between -pi/2 and pi/2, these will cancel each other out and you get back the original angle. If the angle is not between -pi/2 and pi/2, it is too big or way too small outside of these bounds, then what you have to do is you have to replace the angle with another angle, theta prime, that has the same theta, the same value of sine, but that is in the correct interval between -pi/2 and pi/2. Then in that case, they will cancel each other off and you get back the replacement angle. And that's it. Now, that's for sine and its inverse. So you should do the same procedure, treat it exactly the same way if it's cosine and its inverse. However, you know that for cosine and its inverse, the correct interval is not between -pi/2 and pi/2, it is between 0 and pi. So just replace this with 0 and pi, 0 and pi, and it will be exactly the same. And you do the combination of tangent and its inverse similarly. Just use the corresponding intervals that apply for tangent inverse.